Good morning. This is Dr. TF, and here is my submission to the 21st International Conference on Intelligent System Design and Application. So, the manuscript that I have submitted is upon blockchain integrated machine learning for training autonomous cars. So, this has been submitted in December 2021 with the paper ID of 09. So, what I am going to tell about my presentation here is I'm going to give a kind of training to autonomous cars. Okay, by autonomous cars I mean the cars which are of self-driving nature, or unmanned car, or robo cars. Okay, these cars, they don't have any drivers of any sort or any kind of human interaction to control their cruise. Okay, so these cars are called as autonomous cars, or robo cars, or just auto cars. Okay, so how we are trying to employ blockchain and machine learning technology upon this is the core of the paper. So there was a problem, excuse for that. So what we are going to see in this paper is, first we'll go along with the introduction of what is an autonomous car, and what could be blockchain, and what is the technology of machine learning. All these things we'll start up with, and why we are going for this work, the motivation behind the work, followed by the work itself, and finally the conclusion of our work. So first of all, as I told you, the core idea of the manuscript is to train autonomous cars, self-driving cars. So we are having a VANET, a vehicular ad hoc networking. That is the topology that we are trying to employ here, as you can see it here. So in a VANET, what we are trying to do is we are going to have many nodes, which are cars, which behaves as autonomous cars here. So what we are going to do, we are not going to train all those cars as such. We are going to take a single car out of it. There is something like a single node in a VANET, and that particular single node, which mimics a single car, will be trained with precision accuracy. So all this training will be done with precision accuracy. It's going to be accurate and it's going to be precise. And all this training is done by a concept called as DNN, which is dynamic neural network. So it's done by neural network concept, which is powered by AI and machine learning. And the security is given by blockchain. That is the two things that you need to remember. Next, what is an autonomous vehicle? So as I told you in the title slide itself, so autonomous vehicle or autonomous cars are nothing but the self-driving cars. They are otherwise called as autonomous vehicle, auto cars, or robo cars. All these are can be termed as autonomous vehicle. Just as you have cashless transaction these days, we don't use any cash any longer, or even plastic cash or cards of any sort. We just make use of internet banking, or more often like UPI or some kind of GPay or phone pay. All these kind of novel technologies which comfort us with cashless transactions. Similarly, I strongly believe that the future of cruise control, or future of transportation, will be driverless cars. So no human interaction, no human inputted driving vehicles we are going to have in the future. So that is an autonomous vehicle. So all these vehicles are being run by the artificial intelligence, AI concept, and they employ all the machine learning algorithms. We have machine learning algorithms such as random forest, or neural network, or navy base, or all these things are coming under the machine learning approaches. But up here in our work, we try to employ the neural network approach. And all these cars are being produced by companies like Tesla, Ford, and GM. We are aware of it, like the most popular Elon Musk, one of the most influential person in this digital era, is trying to run his way across an autonomous vehicle. We are all aware of, and the giant of, that is the pioneer of automobile industry, the Ford. So they are also trying to produce all this autonomous vehicle up in the years to come. Next, why we are going to go ahead with the driverless car and training that on a driverless automobile. First is because of road accidents. It's been estimated like 1.2 million people die every year on road accidents, and over 50 millions are injured with road accident. Okay, so this is a very shameful thing when it comes to transportation upon roads. So that is a one reason we are going ahead with training of autonomous automobiles. Okay. And again, drivers, when they see a white truck under a bright sky, they can make some mistakes in their cruising. And also, on the contrary, if they see a dark vehicle in a dark night sky without headlamp or tail lamp, they could mistake the fact that there are no vehicles up there. Okay, this could be a trouble, human error point of view. Okay, even in the past, as I given in the last point, there has been some kind of researches that's been done on driverless automobiles, but they have the problem of huge computational times, because they used to train all the nodes separately, unlike our approaches where we try to train a single data set node, and that node we aid it to teach the other nodes. Okay, this is not there in the past, and there are some human interactions that were needed in the past approaches, which is not there in our work. Okay. So what we are trying to do with our work, as you can see from the image up on the left of side of your presentation, you have a trained car, okay, like this, which I put my cursor around it. We do have a trained car with a data set. Okay, this particular node is a single car that we are trying to train. Okay, so when we come to blockchain concept, the public ledger is maintained in this trained car. Okay, all this public ledger can be accessed by all the other cars, so thus the other cars could learn or get trained from this particular trained car. Okay, and there will be a UID for every car in VANET. Okay, there will be a unique ID for every car in VANET, and this particular trained car is called as a teacher car. Okay, what this teacher car does, it's going to teach other cars. Okay, since this car is going to teach all the other cars, the training time or training computation time has been reduced. So these cars will hierarchically try to teach other set of cars that are joining the nodes and something like that. Okay, and we use the BT, that is a blockchain technology, to update the weights after each run. Like if a particular car is running properly, the weight is being updated positively. If the particular data run is done negatively, it's going to get in the negative way. Okay, so on. So, and we try to employ the hybrid blockchain technology to keep the data set and the learning model in private. So the privacy of learning model and the confidentiality of the data set is again an important issue that's been achieved by using the hybrid blockchain technology over here. Okay, so how your car learns. Okay, so what happens, you can see up an yellow car up in the left, it's driving normally, and it finds through the AI mechanism that a collision has happened between a blue truck and a red hatchback. Okay, so a coupe car, so it's getting accident. So it identifies an accident. So what it does is it has a small local memory within it. Okay, that particular memory is going to store the information about an accident with a date and a timestamp, and this information is being given or submitted to all the other cars. So those cars will try to understand about the geography of the accident as well as the date and the timestamp on which the accident has happened. So it will try to deviate itself to the other place, or it will try to make appropriate cruise control measures. So what happens, the particular yellow car which has detected an accident is going to give a date and timestamp to all the other cars. Okay, it's going to give its information to car 2, 3, 4 and 5. Okay, so which means that other cars will get aware of it, and they further teach on other cars that the accident has happened, and thereby they try to avoid that particular path and go in a new favorable path. Okay, so how we are trying to implement our work here, we have used Python and Solidity IDE for our work. And we didn't try a real-time model here. We just used a miniature model, in which we employed 25 different nodes in a VANET topology. Okay, when we talk about 25 different nodes, it means 25 different cars that I used here. Okay, so there was no image processing that is used here. Okay, the image processing will be extra overhead for us. So in a prototype or a miniature model, there were no image processing, so we didn't go for it. Okay, and for each of the 25 cars that have been used, we have employed 5 sensors to detect edges, like one for the front and the back, and a couple for the sides, and one for the track of the road. So we have a total of 5 sensors that are used to detect the track edges. Okay, And for each weight update, we have to alter the control. Okay, each time the weight has been updated in a positive or negative way, the appropriate cruise control mechanisms such as acceleration or the brake or to steer to left and right is being done. Okay, just say for example we have found a accident at one place. The cars that are coming the back has to even kind of take a reversal or put a brake, apply brake, or to steer right and left, and to take a a link disjoint or a secondary path to avoid collision of any kind of sort. Okay, so what happens finally, we have a reward learning technology. What happens when a particular car completes a successful round robin trip? Okay, if it does a full trip successfully, it's given a reward in a positive weight. If it does a round in a negative way, penalty is being given. There is a negative value is being given. Okay, and the next level of training goes along with taking care of zebra crossing, in which the particular car has to apply brake and goes a bit slower, and to avoid plot holes to steer to left and right. Okay, all these things have been done in the next level as well in the form of implementation. Okay. To sum it all up, the time complexity of our thing has been reduced from 1 to n. Okay, in the literature survey, all the existing works, they try to teach each and every node. Okay, but here it's not happening. Okay, we are just going to teach a single node. That single code is going to give the information of training set to n number of nodes, and further on the one from the n node is going to train the new coming nodes into the network. So in that way, we have an hierarchical training program which has been employed by using AI, and since we have used the blockchain into it, the updation of each blocks is happening concurrently. All these things are in a proper way. Okay, so future scope, what we can do is we are try to use some kind of GPS technologies such as Google Maps to reduce the frequency of updation of weights. Okay, here we are trying to update weights in a regular time period, which is not which is an amateurish way of doing it. Further on, when we try to integrate Google Maps into it, we can avoid that one. That could be a future enhancement or future scope of the work in progress that we are trying to put it to you in front of you in this form of presentation. Okay, so that's all what I've got for here, and here are our references which you have got it from a variety of Scopus Indexed and SCI and Web of Science kind of things. Okay, feel free to put any questions, and thank you for the patience of listening, giving me a chance to take this presentation in front of you. Thank you. See you all. Happy hearts.